In this video, we will be showing how to quickly set up the 3D motion capture system and how to perform a couple of different analyses, running and cycling and so on. So let's start with the beginning. Whenever we want to work with a 3D system, we just need to keep in mind these three basic ideas with regard to the system installation. So if the cameras are placed on a new location or the cameras have been moved, we will need to perform at least these 4 steps. First, to make sure that the camera configuration, particularly the exposure, is okay with the location. Second, to apply any masking if needed to avoid strong light sources like a window with sun and so on. Third, to calibrate the system, of course. And finally, to set the reference axis if we want to. Just to briefly explain this last point, the system calibration is run in the same way for any of the protocols. So we can just calibrate the system once and leave it as it is. The same happens with the floor definition, which is by default set by the system. With regard to the reference axis, the system automatically selects direction for each of the 3 axes, X, Y, and Z. This direction usually doesn't affect the biomechanics for most of the protocols, and we can at any point change this reference axis if we want to. For example, in the case of running, setting the reference axis does not affect the biomechanics, but it may affect the views, the orthogonal views of the skeleton. This is, well, something that the user can easily set. How? We will use the 3 points placed like this, perpendicular to the direction of the running direction of the treadmill. I insist that this doesn't affect the biomechanics, just the views of the system. In cycling analysis, the reference axis doesn't really affect at all. In golf swing analysis, we will need to point the x-axis in the direction of the golf swing in the growing x-axis, just to make sure that some of the kinematics are properly calculated. For the standard 19 and any of the other protocols, again, the reference axis does not have any impact at all. So let's go back to the system setup. We have 6 cameras in this case. We will be calibrating the system from scratch. So one of my colleagues is here holding the calibration rod. We will just kick started with the calibration. I'll go to main, configuration, full calibration. He will be moving and tilting the rod to different locations. That's the first one. Second one. That's the third one. He's making sure to tilt, the fourth one, to tilt the rod for each of the takes, just to ensure some proper calibration in the horizontal axis. He keeps, we will try this take again. There was some occlusion going on. Very good. Let's go for one other take. He is trying to draw a sort of grid on the floor with evenly spaced positions for the rod, trying to cover roughly the area that we want to use for the system. Very good. One other position. 6 more to go. There goes another one. As you can see, I used a couple of masks. So before we started, I cleaned the scene just to make sure that I hit some of the spots, but this is what we do on every new location. Very good. That's all right. And the last 2 takes. Very good. And finally, the last one. All right, the system is calibrated. So now, if I show the live video, well, this is exactly one of the spots that I covered with the masks. Let us quickly perform a calibration test. It's just good calibration, obviously, because I just calibrated the system. And just for the sake of curiosity, I'll run test with rod calibration tracking, 7 points calibration rod, real time. This protocol allows me to know how accurate the tracking is working at the different points, so the person can swing the calibration rod, as you can see. Now I know that wherever the calibration rod is green, it means that the positioning is good. It can be horizontal, vertical, or whatever. If for some reason, this is the measurement taken by the system, if for some reason the rod gets out of the system, out of the volume, it will get yellow and then red, and that's because we are pushing the rod too far out of the calibrated area. Okay, so we see we have a very nice and well-distributed calibration in this area. This is what we do for the system calibration. So we check the camera exposure, we perform some masking, in this case a couple of reflections that I wanted to avoid. We calibrate the system, and we will now set the reference axis. We're going to use the system with running and cycling, and maybe a standard 19 analysis. We could just start recording. I'm not going to do a golf swing analysis at the moment, so I could just start and leave the system to decide where the reference axis is set. But just for the sake of getting nice orthogonal views, we will define this reference axis, as I say here, orthogonal to the direction of running. Now to do this, I go to Configuration, Set Reference Frame. This is the this long segment is the one that is drawn like here. Okay, so my colleague plays the markers, and I now hit OK, and the operation was completed successfully. Just to show you where I placed the markers, one second, just to show you where the markers were placed. These are the 3 markers. So we will be placing the treadmill in this direction. Okay, so let's do that. Now the system will be completely set up. I don't need to do anything else. Whenever I'm using a permanent location, I could just call my customers, athletes, runners, whatever. The cameras are already prepared. The only thing I would need to do is, from now on, when I start recording, to take care of these 2 elements in here. So at the beginning of a new day of recording, early in the morning, for example, when you get to the office, to the lab, it is good to check the calibration, which we just did. And then for every new customer or any new analysis that I want to run, I have to make sure that I do this first, which is to check the empty scene to make sure that there is nothing else disturbing. So I would just go to Main tab, Snap, and the scene is clean. So now I know that the treadmill or the bike or any props, any objects that I am using inside the scene are clean. Now I could ask my colleague to get on the treadmill, and we will be placing the markers. Now that we know that the scene is clean, I will just do another snap just to be sure he is wearing some of the markers already. I can see the thigh markers and the calf markers. We're going to perform a running analysis or a gait analysis on the treadmill. So we will now be placing the markers. Just to summarize, we just defined the running direction with the reference axis, and that's something that I don't really need to change. It's set once and for all, as long as I keep the treadmill in that particular position and orientation. So we're using the full body running analysis protocol, which uses one marker on the neck, one on the sacrum, 3 markers per arm, and then the usual lower body configuration for Helen Hayes. If I do a snap right now, I will be getting all those markers. So we're good to go now. We'll do a few recordings. The first one will be just a running analysis, sorry, a gait analysis. So I will set the protocol first. It's the full body analysis, full body running analysis. It will be real time, 40 seconds, maximum recording time. And I will set the treadmill speed at 3.3, which is the walking speed. And I will just hit start. And there we go. I will hide some of these recordings. Sorry, the 2D views, because I'm not interested in that. I will hide some of the elements. You can see the center of gravity, the knee and ankle trajectories, and so on. Let me just stop this one. Some of the parameters are filled right away as soon as we finish the recording. And we will take a look to the data that resulted from the analysis. Well, here are the summary. Here's the summary of the parameters. And so if we take a look to the graphs, here we have the different angle plots. We could zoom in and zoom out as you know very well. We can easily take a look to the event generation. Let me just hide the skeleton to show things more clearly. Well, since I'm on the top view, we can just show that the different views, sorry. So for example, if this is the top view, left camera, perfectly aligned, right view, front view, and so on. But I was going to show the event detection. I'll go to capture camera. We can take a look to the. If I click next page or previous page on the keyboard, I will be switching or jumping to the next event. So let's take a look. This is the right toe off. That's okay. The left toe off. The right foot initial contact. This is the left foot initial contact. Right toe off. This is the left toe off. And there are a few others. If we take a look to the stride dialog in here, we can filter and remove if there is any unusable curves or any unusable cycles. Okay, it's clear enough. I could go to the different joints just to clean everything up, but it looks okay for now. Okay, so let's perform a new analysis, but this time running at a faster speed. Do you want to save? Yes, I want to save this. New analysis, full body. In this case, we will be running at 8 kilometers per hour. We will make sure that the markers are in place. There we go. The initial detection can be done either walking or running. All right, there we go. I'd like to differentiate this recording from the previous one, so I'll save it with a different name. Oops, sorry. In this case, it was running 8 kilometers per hour. Sorry, 8 kilometers per hour. I don't think I renamed the previous one. No, it's okay. We will work with this one. So let's take a look to the event detection, the plots, and everything. Same as before, we have the general spatial temporal parameters and the joint analysis. We take a look to the plots and show some of the curves. Let's take a look to the knee, for example. We can see the slow motion at the beginning, and then we can see the faster motion at the end. Let's take a look to the event detection. Here the person was walking, right toe off, right foot initial contact, oops, left toe off, left foot initial contact. Let's go faster. Let's go faster. Here's the left foot initial contact. Here's the right foot initial contact. Left toe off, right toe off. The system will be taking only the best ones. If there is any mistake in the event detection, which in some strides may happen, this can be easily cleaned by coming to this dialog here. So we have to make sure to do this before we generate the report, just to make sure that the best filtering, the best selection of data is used for the report. I'll filter one more time. I want to make sure that the nicest cycles are used for the analysis. Very good. Let's take a look to the other joints. The knee, hip abduction. Okay, this way we are sure that the best data is available. Okay, so event detection is good, curves are good, tracking is good, curves, everything is ready for the report generation. Let's switch on to the next recording right away. We'll go for the cycling analysis. I want to save this one, so we will just remove the treadmill from there. Let me show the scene here, and we will include the cycling. We don't need to change the calibration. We don't need to redefine the system reference, the reference access of the system. As I said before, there's no need to do that anytime. What I need to make sure is that whenever I start a new analysis with a new protocol, I will make sure that the scene is empty, clean. So we will do a snap now, looking at the bike. Okay, the scene looks nice. There's nothing special to take into account. So now my colleague will be getting on the bike and we will perform the cycling analysis. Just a word on the initial positions. For running analysis, the system is just expecting the athlete to be running on the treadmill. Naturally, there's nothing special to be done. For cycling analysis, the same happens. So the system is expecting the cyclist to be riding on the bicycle. That's it. For golf swing analysis, the system is expecting to see the golfer, the person, bent towards the club and the ball, looking at the ball. And that's the initial position. And for the standard 19, the system expects the subject to be in the center of the area with the arms stretched out to the sides. Okay, let's get back to our scene. We can see here how the markers are being placed. This is the bike fitting protocol for 2018. So we're using 3 markers on the floor. And in the upcoming 2019 protocol, there will be no need to place markers on the floor. Body markers will be the same, but no markers will be placed on the floor, which is very convenient. Okay, so we will start the recording. Again, we go to the new capture dialog. In this case, we select the bike fitting full body analysis, which should be here. Crank length is this one. Recording time, that's it. No need to define anything else. We'll just start the recording. The cyclist can start pedaling anytime, and the system will initiate the tracking, as we can see right away. We'll just stop here. My colleague is not dressed in cycling clothes, so let's not make him sweat. We can take a look to the data, same as before. We can also look at the events, but in this case, the events are just the crank angles moving forward. Again, clean and nice capture. We're just following this little checklist in here. Finally, let's remove the bike and perform a standard 19 recording. Now we don't need any markers on the floor. Let me show the scene. I'll close this one. Well, I forgot to rename the recording. It's okay. We could call it posture, something like this, or initial posture. Then we would technically apply some adjustments on the bike and then measure again to compare the kinematics. Now we will be using the standard 19 protocol. So I go here to the new capture menu, select the full body analysis, standard 19, nothing else to set in here, just the maximum recording time. So let me hit OK. We hit start here, and the person has to stay in T-pose just for the initial recognition, and that's it. If the 3D scene takes a while to load, that's just because computer power. It will just, depending on the power of the computer and the graphic card, it may take just a few seconds. But once the scene is loaded, then the kinematics are just fine. He's free to move inside the volume, as we can see here. Well, this particular protocol doesn't have any event detection. It's just a free motion for full body analysis protocol, and that's it. So just as a summary, here's the list of items that we should make sure to check whenever we install the system at a new location. This is what we need to check when we start a new set of sessions or at the beginning of the day. And then this is what we need to check before we start any recording. So we need to make sure that the scene is empty, place the markers on the right position, and then everything will be smooth and nice. Thank you very much.